Imagine a force so powerful that it can reshape continents, alter climates, and wipe out entire civilizations in a matter of days. Supervolcanoes are the colossal giants of the natural world, capable of erupting with a magnitude that can bring society to its knees. But what exactly makes them so dangerous? A supervolcano is defined by its ability to produce an eruption greater than 1,000 cubic kilometers of volcanic material. This is not a simple lava flow, but a catastrophic explosion that can launch debris many miles into the sky. The last known supervolcanic eruption, the Yellowstone caldera, occurred approximately 640,000 years ago. This eruption released an immense volume of ash and gases into the atmosphere, leading to significant climate changes and even mass extinctions. But as we examine these titanic forces, we begin to realize the chilling potential they hold over our future. They don't just affect local populations, they can alter global climate patterns, leading to what scientists refer to as volcanic winters. What would happen if Yellowstone erupted again? Experts suggest that the outcome could be disastrous. While the likelihood of such an event occurring in our lifetime is low, the ramifications would be monumental. Dust and ash could block sunlight for years, resulting in drastic temperature drops, disrupted food supplies, and an ecological disaster affecting every corner of the globe. The science behind supervolcanoes is complex, and understanding their mechanisms is essential for predicting future activity. Geologists study various signs, such as ground deformation, gas emissions, and seismic activity, to monitor these potential threats. Their work is paramount to developing early warning systems, but they face significant challenges in accurately predicting when and how a supervolcano might erupt. As we dive deeper into the world of supervolcanoes, it's essential to explore the past eruptions that have left their mark on our planet. From the Tambora eruption in Indonesia around 74,000 years ago, which nearly wiped out humanity, to the more recent eruptions of Mount Pinatubo in 1991, which caused a global cooling effect, these events serve as stark reminders of nature's unpredictability. The stakes cannot be higher, and the need for preparedness is crucial. Scientists and governments worldwide are working collaboratively to develop strategies that could mitigate the devastating effects of these natural disasters. But as we uncover the hidden dangers of supervolcanoes, we must also explore their historical impact to fully grasp the consequences of an eruption. So, what can history teach us about the future? If the very ground beneath our feet could erupt, how can we possibly prepare for the unthinkable? In the next chapter, we will journey through the timeline of catastrophic eruptions and their lasting consequences. Throughout history, our planet has been shaped by the fury of volcanic eruptions. They have marked significant moments in our geological timeline and provided insights into the risks we face today. Let's take a closer look at some of the most monumental eruptions that have changed the course of history. One of the earliest known catastrophic eruptions was the eruption of Mount Tambora in Indonesia in 1815. This eruption is often cited as the catalyst for the year without a summer in 1816, a global climate anomaly that brought frost and snow to several parts of Europe and North America. The ash released into the atmosphere disrupted weather patterns, leading to widespread crop failures and food shortages, events that contributed to mass migrations and humanitarian crises. As we analyze these past eruptions, it becomes evident that the ramifications are not just environmental, but deeply intertwined with human society. The story of Tambora is a poignant reminder of how natural disasters can directly affect human lives, economies, and social structures. One could say that nature's wrath brought about not only physical destruction but also societal upheaval. Another significant event in history is the eruption of Mount Vesuvius in AD 79, which obliterated the Roman cities of Pompeii and Herculaneum. The speed at which the eruption occurred left little time for residents to escape, entombing them in ash and preserving a snapshot of life in ancient Rome. This eruption is an enduring reminder of the destructive capabilities of volcanoes and how quickly they can change the narrative of civilization. The archaeological excavations at Pompeii have revealed much about Roman life, but they also serve as a stark warning of our vulnerability. No civilization is immune to the forces of nature. What makes modern society more susceptible? The rapid urbanization and interconnectedness of our world mean that the effects of a volcanic eruption could ripple across the globe in ways we are just beginning to understand. Consider the eruption of Krakatoa in 1883, which produced one of the loudest sounds ever recorded in history. The atmospheric effects were felt worldwide, causing temperature drops and bizarre weather patterns. It's a testament to the interconnectedness of our planet. What happens in one part of the world can resonate far and wide, highlighting the idea that no nation is an island, especially in the realm of natural disasters. As we reflect on these historical eruptions, we can discern patterns and themes that resonate with the present day. The lessons of the past offer critical insights for preparing for future volcanic threats, but are we really learning? The fine line between scientific knowledge and public perception can often skew our understanding of risk. In the case of supervolcanoes, the unpredictability of their eruptions presents a unique challenge for scientists tasked with communicating these risks to the public. Why is it that, despite these historical lessons, we often fail to prepare adequately for future catastrophes? In the following chapter, we will delve into the latest research and predictions surrounding the most dangerous volcanoes today and the implications for our future. As we step into the present, we are surrounded by a plethora of volcanoes that pose potential threats to our existence. Our modern world is interwoven with these geological titans, from the iconic peaks of the Andes to the vast calderas of the Pacific Ring of Fire. Among the most scrutinized volcanoes today is Yellowstone, not just for its beauty and geothermal activity but for its undeniable potential for catastrophic eruption. Scientists continuously monitor its seismic activity, ground uplift, and gas emissions, all of which provide clues about its future behavior. Yet, what if these indicators fail to give us enough warning? In addition to Yellowstone, the volcanoes of the Pacific Ring of Fire are among the most active and hazardous. Mount St. Helens in Washington state, which erupted in 1980, serves as a chilling reminder of nature's power. The eruption not only reshaped the landscape but also impacted air quality and local ecosystems. What would happen if a larger volcano in this region erupted? Experts are particularly concerned about the potential of Mount Rainier, which looms ominously over Seattle. The threat is not just from an explosive eruption, but also from lahars, volcanic mudflows that can devastate communities. Cities like Tacoma and Seattle could find themselves unprepared for the wrath of nature. Across the globe, in the Mediterranean, Mount Etna stands as a vigilant giant. Known for its frequent eruptions, it keeps scientists on their toes. The question remains, could it unleash a supereruption similar to that of Toba or Tiamu Massif? The unpredictability of volcanoes complicates our efforts to predict their behavior and the necessary precautions we should take. Recent volcanic activity has shown us that even long-dormant volcanoes can awaken, causing chaos in their path. The 2010 eruption of Eyjafjallajökull in Iceland may not have been the most powerful, but it demonstrated how quickly volcanic ash can disrupt air travel and affect economies worldwide. As we explore these volcanoes, it's imperative to ask ourselves, are we adequately prepared for the next big eruption? Scientists are racing against time to improve eruption prediction techniques and enhance public awareness of volcanic risks. But with climate change altering Earth's systems, how will that impact volcanic activity? In the next chapter, we will dissect the interplay between climate change and volcanism, revealing how one disaster could feed into another. As we grapple with climate change, we must also recognize its potential interactions with volcanic activity. The Earth is a complex and interconnected system where changes in one area can trigger reactions in another. Rising temperatures and melting glaciers can influence volcanic eruptions in various ways. For example, the weight of ice resting on a volcano can suppress magma movement. When that weight is lifted due to melting, magma can surge upward, increasing the potential for an eruption. This phenomenon has been observed in several regions, including Iceland, where rapid climate change is reawakening dormant systems. Moreover, the increased precipitation associated with climate change can lead to more significant erosion and landslides, triggering volcanic activity as well. It's a vicious cycle where climate change and volcanism feed into each other, leading to potentially catastrophic outcomes. Consider the eruption of Krakatoa, where changes in sea level and climate dynamics were believed to contribute to its explosive activity. Scientists continue to study these connections to understand how future eruptions may be influenced by the shifting climate landscape. The implications of this research are staggering. If global temperatures rise significantly, how many dormant volcanoes could awaken? As we delve deeper into the science, we find that the stakes are not just environmental, but socioeconomic as well. The communities surrounding volcanoes often depend on the land for agriculture and tourism. A volcanic eruption can displace thousands, leading to increased poverty and social instability. The interaction between climate change and volcanism is not just a scientific curiosity, it has real-world consequences for millions of people. It raises a crucial question: how can we as a society prepare for the combo of climate-driven disasters and volcanic threats? In the next chapter, we will look at the scientific advancements in monitoring and predicting volcanic activity and how they can save lives. In the face of impending threats from volcanoes, scientists and researchers are developing cutting-edge technology to monitor and predict volcanic activity. But how effective can these systems be in providing early warnings? One of the most critical tools in volcanology today is the use of satellite imagery to analyze surface changes. Satellites equipped with specific sensors can detect thermal anomalies, ground deformation, and gas emissions from volcanoes. This data provides scientists with invaluable insights into volcanic behavior and the likelihood of eruptions. In addition to satellite technology, seismic monitoring networks are essential for understanding volcanic activity. Sensors placed on the ground track minor earthquakes, which often precede larger eruptions. These vibrations can help scientists map lava flow pathways and understand magma movement within the Earth. However, predicting eruptions remains a complex challenge. Historical data and modeling efforts can provide estimates, but every volcano behaves uniquely. The question remains, how can we improve our predictive models? Recent advancements in machine learning and data analysis are promising. By inputting vast amounts of historical eruption data into algorithms, researchers are beginning to generate more accurate predictions. But these technologies also require collaboration across countries and disciplines to be effective. The story of Mount Merapi in Indonesia serves as an example of how effective monitoring can save lives. In 2010, scientists successfully predicted an eruption, leading to timely evacuations that spared thousands from potential disaster. This has led to increased funding for monitoring programs around the world, emphasizing the need for preparedness and community engagement. As we consider the future, it's critical to ask ourselves, how can we bridge the gap between scientific research and public awareness? With effective communication and education, communities can better prepare for volcanic threats. As we conclude this first part of our exploration into volcanoes that could end civilization, we must remain aware and vigilant. What other strategies exist to navigate these unpredictable forces of nature? In the subsequent chapters, we will delve deeper into potential solutions and innovations to mitigate volcanic risks. Imagine a world where the sky darkens, crops fail, and civilization as we know it crumbles under the weight of ash and despair. A single catastrophic volcanic eruption can trigger a domino effect, impacting climate, agriculture, and ultimately the very foundation of society. Let's explore how a supervolcanic eruption like that of the Toba catastrophe about 74,000 years ago reshaped the planet and threatens us even today. The Toba eruption spewed an estimated 2,800 cubic kilometers of volcanic material into the atmosphere, causing a prolonged volcanic winter. Evidence suggests that this event may have reduced the human population to fewer than 15,000 individuals, a bottleneck we are still grappling with genetically today. In the modern era, we must grapple with the realization that a similar event could trigger a cascade of global disasters. For instance, a volcanic eruption at Yellowstone National Park, one of the world's most closely monitored supervolcanoes, could produce ash clouds stretching thousands of kilometers, potentially disrupting air travel and causing widespread food scarcity. Just in 2010, the eruption of Eyjafjallajökull in Iceland had immediate and severe impacts on global air traffic, showcasing the sheer power of volcanic activity to create chaos. Government agencies and experts estimate that a supervolcano eruption could lead to billions of dollars in economic losses and a death toll in the millions over time. It's not just the eruption itself but the subsequent fallout, food shortages, economic collapse, and mass migration would all contribute to the end of civilization as we know it. Today, we continue to study and prepare for such catastrophic events, but the threat looms larger than ever. Will humanity be ready when the Earth unleashes its fury once again? Stay tuned as we discover the narrative of survival and adaptation in the face of impending doom. In the face of volcanic disasters, humanity has often shown incredible resilience and adaptability. Throughout history, communities have learned to live alongside the ever-looming threat of volcanoes, adapting their lives, cultures, and economies to mitigate the risks. Take, for example, the people of Mount Etna in Italy. Eruptions have shaped their history for thousands of years, turning what could be a crippling threat into an integral part of their identity. The fertile volcanic soil has allowed for rich agricultural production, from grapes to olives, which have become staples of the local economy. However, it's not just about thriving alongside nature, it's about building a culture of safety and preparedness. In 2014, Etna's eruption prompted evacuation protocols that successfully saved thousands of lives. This adaptability is echoed in other regions as well, such as the island of Hawaii. The Kilauea volcano is one of the most active on the planet, and local communities have become adept at addressing the threats it poses. However, as climate change alters volcanic activity patterns, the risks may increase. Resilience must continually evolve. What worked in the past may not suffice for the future. Human ingenuity must be coupled with scientific understanding to prepare for what's coming. The story of how societies respond to volcanic threats offers a glimpse into humanity's capacity to not just survive but thrive despite the odds. But how far can this resilience truly stretch before it snaps under pressure? As we inch closer to potential volcanic catastrophes, our reliance on emerging technologies for prediction and monitoring has never been more critical. In recent years, scientists have developed innovative methods using satellite data, seismic sensors, and AI to gauge volcanic activity. Predicting when a volcano will erupt is one of the most challenging tasks facing volcanologists today. According to various studies, researchers now utilize a combination of techniques to assess volcanic gas emissions, thermal anomalies, and ground deformation, creating a comprehensive picture of a volcano's health. The 2018 eruption of Kilauea in Hawaii exemplified the necessity of accurate data. Thanks to advanced monitoring systems, scientists were able to provide crucial warnings that assisted in timely evacuations. However, prediction is not foolproof, and the unpredictable nature of volcanic systems means that innovation must continue. Future technologies could include drones and remote sensing systems that can collect data from hazardous areas without putting human lives at risk. Moreover, public access to real-time data can empower communities to make informed decisions about their safety. Imagine a world where the threat of volcanic eruptions is significantly diminished through our understanding and respect for these powerful natural phenomena. But will technological advancements keep pace with the growing threats posed by our changing planet? As volcanic threats loom larger, the role of education and awareness becomes paramount. Knowledge is our most powerful tool in mitigating disaster and fostering resilience. To prepare communities for the inevitable, educational programs must inform people about the signs of volcanic unrest, evacuation routes, and the importance of emergency kits. Countries like Japan, situated along the Ring of Fire, have implemented comprehensive public awareness campaigns focusing on volcano safety and preparedness. Following the devastating eruption of Mount Pinatubo in 1991, the lessons learned became valuable for nations worldwide. Thousands of lives were saved thanks to effective evacuation plans, which were the result of thorough education and simulation drills. In many regions, schools are now teaching children about volcanoes from a young age, instilling a sense of both respect and caution. But it's not just about formal education. Social media and online platforms have opened new avenues for disseminating critical information quickly. Communities can share updates and experiences, building a network of vigilance against natural disasters. However, as misinformation can spread as rapidly as facts, the importance of reliable sources cannot be overstated. How can communities ensure they are not just prepared, but also informed with the most accurate data when the time comes? As we conclude this exploration into the volcanoes that could end civilization, we are left with a profound understanding of the delicate balance we share with our planet. Every eruption carries with it the potential for destruction, but also a reminder of the forces that have shaped our world for millennia. Our future hinges on our ability to blend scientific understanding with cultural adaptability, embracing both technology and education to create resilient communities. The story of humanity is one of resilience, challenge, and sometimes catastrophic upheaval, and in this light, our relationship with volcanoes serves as a mirror reflecting our strengths and vulnerabilities. It's clear that as we move into an uncertain future, our survival may depend on how well we prepare for the worst while hoping for the best. Will we rise to the challenge, or will we be caught unprepared when the next big eruption occurs? One thing remains certain: the Earth will continue to shape our destiny, and the lessons learned from our volcanic past will guide us. As we continue to explore the wonders of science and the universe, let us remember, we are not separate from nature but intricately woven into its tapestry. Understanding the mechanics of volcanic eruptions is crucial to grasping their potential impacts on civilization. At the heart of every eruption lies tectonic activity, a chaotic yet fascinating dance beneath the Earth's crust. The planet is dotted with tectonic plates, and when these massive sections shift or collide, pressure builds up, often resulting in volcanic eruptions. Take, for instance, the Cascadia subduction zone, located off the coast of the Pacific Northwest. This area is a prime example of tectonic interaction. Here, the Juan de Fuca plate plunges beneath the North American plate. As this oceanic plate slowly descends, it melts, creating magma that can eventually lead to explosive eruptions. But it's not just the tectonics that matter. The chemical composition of the magma plays a significant role too. Magma rich in silica tends to trap gases, leading to more explosive eruptions. On the other hand, low silica magma flows more easily, resulting in less violent outcomes. Mount St. Helens, which erupted dramatically in 1980, exemplifies this. The eruption's explosive nature stemmed from its gas-rich, high-silica magma. Throughout history, our understanding of these processes has evolved. Ancient cultures revered volcanoes, often attributing their eruptions to the wrath of gods. However, modern science has unraveled these myths, revealing the natural forces at play. Today, we study volcanoes with groundbreaking technologies, assessing magma movements and gas emissions to predict eruptions. Interestingly, not all volcanoes erupt. Many remain dormant for centuries, leading to debates about their potential threat. The Yellowstone supervolcano is a prime example. It last erupted approximately 640,000 years ago, yet it remains a significant concern for scientists. A supereruption could blanket large swathes of North America in ash, disrupt global climate, and plunge humanity into chaos. To put this in perspective, the ash from the Yellowstone supervolcano could travel thousands of miles, causing agricultural failures and widespread famine. In conclusion, delving into the science behind eruptions reveals the intricate workings of our planet. This understanding not only highlights the risks we face but also underscores humanity's need to prepare for potential volcanic catastrophes. As we explore further into the risks and impacts, the real question remains: how ready are we for the next eruption? Volcanic eruptions have not only shaped landscapes but have also significantly influenced human culture and society throughout history. From ancient civilizations to modern societies, the impact of these natural disasters has been profound and far-reaching. Let's begin with the eruption of Mount Vesuvius in 79 AD, which famously buried the Roman city of Pompeii. The sudden eruption caused a rain of ash and pumice that encapsulated the city, preserving it for centuries. Today, Pompeii offers a remarkable snapshot of Roman life, frozen in time, providing rich archaeological insights into urban planning, art, and daily activities. The tragedy of Pompeii serves as a reminder of nature's unpredictable power and the thin veneer of civilization. But it's not just ancient history that showcases volcanic impact. In more recent times, the eruption of Mount St. Helens in 1980 resulted in significant societal changes. The eruption, which was preceded by a period of seismic activity, led to extensive evacuation efforts. The lives of thousands were uprooted, and communities had to be rebuilt. The Federal Emergency Management Agency, or FEMA, played a crucial role in disaster response, setting a precedent for how government agencies respond to natural disasters. This event highlighted the importance of emergency preparedness in the face of volcanic threats. Culturally, these eruptions have left indelible marks on the collective psyche of societies. The folklore of many cultures is filled with accounts of volcanoes, often seen as powerful deities. For example, in the Hawaiian culture, the goddess Pele symbolizes the volcano itself, embodying both creation and destruction. The stories surrounding her are intertwined with the land and its people, showcasing how volcanic activity influences identity and heritage. Moreover, the socio-political dimensions of volcanic eruptions cannot be ignored. The 1991 eruption of Mount Pinatubo in the Philippines led to substantial geopolitical shifts. The eruption was one of the largest of the 20th century, displacing thousands and affecting air travel worldwide for months. The aftermath saw the U.S. military base at Clark Air Base closed permanently, altering the dynamics of U.S.-Philippine relations. This event underscores how natural disasters can reshape not only landscapes but also human relationships and power structures. As we reflect on the cultural and societal implications of these volcanic events, one question lingers: how do we prepare for the unpredictable forces of nature in a way that honors our shared history and cultural ties? Understanding the past can guide us in shaping a more resilient future. As we delve deeper into the realm of volcanic threats, it becomes evident that a robust global network for monitoring volcanic activity is essential. This is where organizations like the Global Volcanism Program and the United Nations Office for Disaster Risk Reduction come into play. Their mission is clear: to mitigate the risks associated with volcanic eruptions through research, data collection, and public awareness. Central to this effort is the use of advanced technology. Satellite imagery and ground-based sensors allow scientists to monitor changes in volcanic behavior. For example, satellite radar can detect ground deformation as magma rises beneath the surface, a key indicator of potential eruptions. Additionally, gas emissions, like sulfur dioxide, are monitored to gauge volcanic activity. These advancements in monitoring are paramount in providing early warnings, enabling evacuations and preparation that can save countless lives. One successful case study is the 2010 eruption of Eyjafjallajökull in Iceland. This volcano erupted unexpectedly, leading to significant disruption of air travel across Europe. Fortunately, the Icelandic Meteorological Office had been monitoring volcanic activity closely. Their early warning systems allowed for timely evacuations and potentially mitigated the disaster's impact. This incident underscored the importance of global cooperation in volcanic monitoring, as scientists around the world shared data and strategies to manage the crisis effectively. Education and community involvement also play vital roles in volcano preparedness. Countries located near active volcanoes often engage in annual drills to prepare residents for potential eruptions. These drills, combined with public awareness campaigns, empower communities to respond effectively when the threat arises. Internationally, collaborations like the Volcano and Geothermal Energy Conference foster the exchange of knowledge and best practices in managing volcanic risks. Scientists, governments, and local communities come together to share experiences, enhancing global preparedness for future eruptions. But amidst all these advancements, the question remains, are we doing enough to protect humanity from the catastrophic threats of volcanoes? As we look toward the future, the call for innovation in monitoring techniques, coupled with community engagement, becomes more apparent. Balancing science with local knowledge can lead to more resilient societies in the face of inevitable volcanic threats. And therein lies both our challenge and opportunity, ensuring that we not only survive but thrive in a world shaped by powerful natural forces. Volcanic eruptions are not merely geological occurrences. They are complex processes that involve the interplay of various geological and physical factors. At the heart of this process lies magma, a molten rock that originates from the Earth's mantle. When the pressure of magma builds up, it finds its way to the surface through cracks in the Earth's crust, resulting in explosive eruptions. This eruption can release ash, gas, and molten lava that can travel for miles, causing destruction and changing landscapes. There are several types of volcanic eruptions, each with unique characteristics. For instance, a Hawaiian eruption is characterized by the gentle outpouring of lava, while a Plinian eruption is marked by the explosive expulsion of volcanic ash and gas. This distinction not only helps scientists understand volcanic behavior but also assists in predicting potential hazards associated with different volcano types. Understanding volcanic eruptions requires knowledge of several geological concepts, including plate tectonics and the types of rocks involved. The movement of tectonic plates can cause stress in the crust, leading to the creation of volcanoes. For example, the Pacific Ring of Fire is an area where several tectonic plates meet, resulting in a high concentration of volcanoes. Furthermore, the chemical composition of the magma plays an essential role in determining the eruption's intensity. Magma rich in silica is more viscous and tends to trap gases, resulting in violent eruptions. In contrast, basaltic magma, which is lower in silica, tends to flow more freely, leading to more gentle eruptions. Analyzing these characteristics can help scientists identify signs of an impending eruption. To illustrate the unpredictable nature of volcanic eruptions, one can look at the 1980 eruption of Mount St. Helens in Washington state. Before the event, the volcano showed little signs of activity, but within weeks, it transformed dramatically, culminating in a major explosive eruption that reshaped the surrounding landscape. This eruption teaches us that even seemingly dormant volcanoes can be awakened by geological forces. In conclusion, understanding the science behind volcanic eruptions is crucial for predicting and mitigating their impact on civilization. As research continues, new discoveries will likely reshape our understanding of these natural phenomena, providing even more insights into the potential threats they pose. The only question that remains is, how prepared are we for the next big eruption? Volcanic eruptions are more than geological events. They have profound effects on human societies and cultures. Throughout history, eruptions have inspired myths, shaped civilizations, and even influenced political landscapes. For example, the eruption of Mount Vesuvius in AD 79 not only obliterated the Roman cities of Pompeii and Herculaneum but also preserved them beneath layers of ash, providing a unique window into Roman life. Beyond historical lessons, volcanic eruptions continue to affect modern-day societies. The Age of Geological Eruption in Iceland in 2010 serves as a contemporary case study. This seemingly small eruption had far-reaching consequences for global air travel, leading to flight cancellations across Europe and demonstrating just how interconnected our world has become. The impact of these eruptions on local communities can be devastating. People living in the shadow of volcanoes often face the constant threat of evacuation, loss of homes, and livelihood disruptions. For instance, the 1991 eruption of Mount Pinatubo in the Philippines led to the displacement of thousands of residents, revealing the human costs associated with volcanic activity. In many cases, local cultures have adapted to living with volcanoes. In Indonesia, for instance, many communities view volcanoes as sacred, integrating them into their spiritual practices. This cultural reverence can foster a sense of resilience, yet it can also complicate evacuation efforts when eruptions occur. Another aspect of societal impact is the economic ramifications of volcanic eruptions. Agriculture often suffers immediately following an eruption due to ash fall, which can contaminate crops. Yet, in the long term, volcanic soil can be highly fertile, allowing for agricultural recovery and growth. Additionally, tourism can be both positively and negatively affected. While active volcanoes can attract tourists, an eruption can devastate local economies that rely on travel and hospitality. The balance between promoting tourism and ensuring safety becomes a crucial challenge. After the 2018 eruption of Kilauea in Hawaii, the local economy saw a sharp decline as tourists avoided the area due to safety concerns. In summary, the cultural and societal impacts of volcanic eruptions are profound and multifaceted. As we confront the possibility of future eruptions, understanding these impacts allows us to create better strategies for disaster preparedness and community resilience. The question remains, how can societies strike a balance between respecting the power of volcanoes while also protecting their residents? As the threat of volcanic eruptions looms over many regions around the globe, the significance of monitoring these geological giants has never been more critical. Organizations worldwide are dedicated to the task of observing and understanding volcanic activity to protect human life and mitigate potential disasters. One of the key players in this field is the Global Volcanism Program, which tracks volcano activity worldwide and has amassed an impressive database of eruptions. This information is crucial for research and plays a vital role in disaster preparedness. Technological advancements have revolutionized the way we monitor volcanoes. Seismographs detect earthquakes that often precede eruptions, while satellite imaging allows scientists to observe changes in the landscape around volcanoes, such as ground deformation and thermal activity. One notable example of effective monitoring is the work done at the Mauna Loa Observatory in Hawaii. Despite being one of the world's most active volcanoes, advancements in monitoring technology have enabled scientists to predict eruptions with increasing accuracy. This foresight allows local authorities to implement evacuation plans well in advance, reducing the risks to human life. However, the challenge remains. Not all eruptions provide clear warning signs. The 2018 eruption of Kilauea caught many by surprise despite ongoing monitoring efforts, highlighting the limitations of current technology. International collaboration is also essential for successful volcanic monitoring. Countries frequently share data and resources, recognizing that volcanic activity is a global issue. For instance, the European Space Agency collaborates with national geological services to track volcanic gases emitted during eruptions, which can significantly impact global climate patterns. In conclusion, the Global Volcanic Watch represents humanity's ongoing quest to understand and mitigate the threats posed by volcanoes. As our technological capabilities grow, so does our responsibility to protect lives and ecosystems from unpredictable eruptions. The looming question is, as we develop more sophisticated tools and strategies, will we ever truly be able to predict the unpredictable? When we think about volcanoes, we often picture the glowing lava flows and dramatic eruptions that capture our attention. But lurking beneath the surface of our planet are supervolcanoes, colossal magma chambers that can unleash catastrophic eruptions. To understand their power, we need to delve into their formation and dynamics. Supervolcanoes are characterized by their vast calderas, giant craters caused by explosive volcanic activity. They form over thousands of years, accumulating magma beneath the Earth's crust, until the pressure reaches a tipping point. This explosive potential is not something we can ignore. One of the most famous supervolcanoes is the Yellowstone caldera in the United States. This massive geological feature is about 30 miles, 48 kilometers, wide and has experienced 3 major eruptions in the last 2.1 million years, the last being approximately 640,000 years ago. Each of these eruptions released thousands of cubic kilometers of ash and pumice. Scientists believe another eruption could occur, potentially releasing even more than before. But what would it mean for us? A study published in the journal Nature estimates that a super-eruption could inject millions of tons of ash into the atmosphere, leading to a volcanic winter. This could cause global temperatures to drop by several degrees Celsius, disrupting agriculture and leading to food shortages. In an interconnected world, this kind of climate disruption would have far-reaching consequences, spiraling into economic instability and social unrest. But Yellowstone is not alone. Around the world, there are many other supervolcanoes, such as Campi Flegrei in Italy and Toba in Indonesia. Each of these sites has a history of catastrophic eruptions, and the potential for future activity cannot be overlooked. For instance, the eruption of Mount Toba around 74,000 years ago is believed to have led to a global volcanic winter, reducing the human population to a few thousand individuals. Such devastating events remind us that our existence is precariously perched on the edge of natural forces that we do not fully understand. As we continue to study these geological giants, one question looms large: how prepared are we to face the consequences of a supervolcanic eruption? Scientists are actively researching, but as history has shown, our understanding is often outpaced by nature's fury. This chapter sets the stage for the dangers that lurk beneath the Earth's surface, and the balance we must maintain with these natural titans, as we move forward into our exploration of historical lessons learned from eruptions. What will we learn from the past? In a world where volcanic eruptions could potentially end civilization as we know it, the question arises: how do we prepare for such catastrophic events? It's a question that involves not only government planning but community resilience and infrastructure readiness. The reality is, while we may not be able to prevent an eruption, we can certainly mitigate its effects through robust planning and preparedness strategies. One of the most effective ways to deal with volcanic disasters is to invest in resilient infrastructure. This means building roads, bridges, and buildings that can withstand the forces of nature. For instance, Japan has implemented extensive engineering solutions in areas prone to volcanic activity. Their construction codes require buildings to be designed with the latest seismic and volcanic standards in mind. When Mount Sakurajima erupted, the city was largely unharmed due to these measures, showcasing the importance of preparedness. Furthermore, a significant aspect of preparation involves establishing early warning systems. These systems rely on a combination of technology and scientific research to detect signs of volcanic activity. The Hawaiian Volcano Observatory has been a pioneer in this regard, utilizing seismographs and GPS technology to monitor volcanic activity in real time. This allows for timely evacuations and emergency planning, which can save countless lives. In addition to technology and infrastructure, public education plays a critical role in resilience. Communities located near active volcanoes must be informed about eruption risks and prepared with emergency plans. For example, in Italy, where the Vesuvio volcano poses a significant threat to nearby cities, educational campaigns have increased awareness and preparedness among residents. These efforts can mean the difference between chaos and effective evacuation during an eruption. As we look to the future, we must ask ourselves, are we ready? The potential for catastrophic eruptions necessitates ongoing investment in infrastructure, technology, and education. As climate change continues to alter volcanic activity, our preparedness strategies must evolve. How will we adapt to these looming threats, and are we ready for the challenge? This question leads us into the critical role of global cooperation when faced with impending volcanic threats. Can nations unite to form effective response strategies? When faced with the threat of volcanic eruptions that could disrupt or end civilization as we know it, collaboration becomes an essential part of our response. No longer can nations afford to approach this challenge in isolation. The stakes are too high. Global cooperation is crucial in sharing knowledge, resources, and strategies that can effectively mitigate the impacts of volcanic activity. Historically, we have seen successful collaborations in various fields of disaster management. The UN's International Strategy for Disaster Reduction, UNISTR, facilitates cooperation among countries to develop disaster-resilient policies. An example comes from the 2010 eruption of Eyjafjallajökull in Iceland, which paralyzed air travel across Europe. The swift response and coordination among European countries showcased the power of collaboration in crisis management. Countries pooled their resources to better handle the fallout, highlighting how collective efforts can ease the burden of a volcanic crisis. Furthermore, organizations such as the International Association of Volcanology and Chemistry of the Earth's Interior, IFCI, are at the forefront of global volcanic research. They bring together scientists from various countries to share volcanic data and conduct joint research initiatives, which is vital for understanding eruption patterns and improving forecasting models. This kind of interdisciplinary teamwork not only enhances our scientific understanding but also strengthens the global network of volcano monitoring. In addition to scientific collaboration, we can learn from indigenous knowledge, which has long emphasized understanding the natural world through lived experience. Communities living near volcanoes have invaluable insights into warning signs and behaviors associated with eruptions. This traditional knowledge complements modern science, creating a more comprehensive understanding of volcanic risks. By incorporating these perspectives into our response strategies, we can enhance our preparedness efforts. As we explore global cooperation in the face of volcanic threats, one question emerges: how can we build a united front to effectively confront the challenges posed by volcanoes? The answer lies in fostering partnerships, advocating for policies that prioritize volcanic research, and promoting community engagement. In an era where humanity faces increasing natural threats, can we rise to the occasion and collaborate as a global community? This exploration leads us to contemplate the future. How will we adapt and respond to the unraveling tapestry of volcanic threats that loom ahead? Volcanic eruptions are often defined by their spectacular lava flows, ash clouds, and the terrifying roar of nature's fury. However, one of the most insidious elements lurking in the aftermath of such eruptions is the release of volcanic gases. Gases like sulfur dioxide and carbon dioxide can escape from magma long before an eruption and can create dire consequences for human health and the environment. In fact, during the infamous eruption of Mount Pinatubo in 1991, the release of sulfur dioxide into the stratosphere not only led to climate anomalies but also impacted air quality globally. But why is this so significant? The answer lies in the very fabric of our atmosphere and how volcanic gases interact with it. The eruption of Mount Pinatubo was one of the largest of the 20th century, displacing around 20 million people, and infusing the atmosphere with an estimated 20 million tons of sulfur dioxide. This gas formed sulfate aerosols, which effectively reflected sunlight and led to a temporary cooling period across the globe of nearly half a degree Celsius. Imagine the ripple effects: agricultural cycles disrupted, ecosystems suffering, and communities grappling with the loss of crops and livelihoods. Moreover, it's not just the immediate aftermath that we must concern ourselves with. Long-term exposure to these pollutants can exacerbate respiratory diseases and lead to health crises, especially in vulnerable populations. For instance, studies following the Pinatubo eruption indicated increased rates of respiratory illnesses in regions surrounding the volcano, illustrating that even after the eruption, the consequences linger like a ghost. But what about the gases themselves? Sulfur dioxide, when airborne, transforms into sulfuric acid when it interacts with water vapor. This means that rain falling after a volcanic eruption could be laced with acid, further affecting water supplies. These phenomena illustrate how complex and multifaceted the threats from volcanic gases can be. Yet, they are often overlooked in the grand narrative of natural disasters. As we delve deeper, we realize that many supervolcanoes, like the Yellowstone caldera, are ticking time bombs. These giants can release massive quantities of gas even during non-eruptive phases. History records that a supereruption at Yellowstone could blanket the United States in ash, disrupt global temperatures, and unleash a cascade of volcanic gases that would cripple agriculture for years. What does this mean? We are not just facing geological threats but a complex web of biogeochemical consequences that could unravel society as we know it. The lessons from Mount Pinatubo and the understanding of gases released during eruptions remind us of the need for comprehensive monitoring systems. Innovations in atmospheric science allow us to measure not just the gases released, but also their potential impacts. Imagine a world where we could predict these threats with high accuracy, saving lives, protecting economies, and preserving the integrity of our ecosystems. As we move toward the future, the importance of understanding volcanic gases as a significant threat to civilization cannot be overstated. What would it take to ensure our readiness against such hidden threats? Throughout history, volcanic eruptions have not only posed immediate threats to life and property but have also had far-reaching consequences that have reshaped entire populations. During catastrophic events, people are often forced to leave their homes, leading to migrations that can alter societal dynamics significantly. As we stand on the brink of the next inevitable eruption, we must examine how such natural disasters could force global migration on an unprecedented scale. One of the most profound examples comes from the eruption of Mount Vesuvius in AD 79, which buried the cities of Pompeii and Herculaneum. The tragedy led to a significant loss of life and forced survivors to scatter to neighboring regions. This was not merely a local disaster, it shifted the population dynamics of the entire Roman Empire as people sought refuge and work elsewhere. Such historical precedents are reminders that the impact of volcanic eruptions is often felt far beyond the immediate vicinity of the eruption site. Fast forward to today, we face a similar scenario with volcanoes like La Soufrière on St. Vincent, which erupted in 2021. Thousands were evacuated, displacing entire communities and affecting the livelihood of residents. With climate change intensifying the frequency and effects of natural disasters, we must ask ourselves, What happens when these eruptions coincide with rising sea levels and extreme weather events? According to a recent study published in Nature Climate Change, researchers estimate that volcanic eruptions could displace millions in the coming century. If a supervolcano like Yellowstone were to erupt, the ash fallout could render vast swathes of land inhospitable. This has prompted scientists to model potential migration patterns, suggesting that nations not prepared for such an influx could face severe social unrest as resources dwindle and competition rises. Countries like Canada and Australia may see a surge in migrants seeking safety from volcanic fallout, reshaping their demographic landscapes. This raises critical questions about social integration, cultural preservation, and economic adaptation. How will societies cope with an influx of people bringing diverse experiences but also differing needs? As governments and organizations prepare for potential eruptions, understanding the components of volcanic disaster response is essential. Creating plans that encompass shelter, food security, and healthcare access will be critical elements in managing future migration caused by volcanic threats. Moreover, this is not just a challenge for the immediate aftermath but also an opportunity to rethink how societies are structured. Resilience becomes the catchphrase. Societies will need the capacity to absorb shocks and to integrate displaced populations. Have we learned enough from past eruptions to mitigate the impact of the next big one? In conclusion, as we face the possibility of future eruptions, it's crucial to recognize the migration patterns that may arise from them. Volcanic eruptions could become catalysts for significant shifts in global population dynamics. The question remains, are we prepared for the societal transformations that will inevitably come with these natural disasters? As the world evolves, so too does our approach to natural disasters. Volcanic eruptions pose substantial threats to civilization, but advancements in technology have the potential to mitigate these risks dramatically. The intersection of technology and volcanic monitoring presents opportunities to enhance our understanding, preparedness, and responses to one of nature's most formidable forces. Consider the case of the eruption of Mount St. Helens in 1980. Researchers and volcanologists were caught off guard, and the subsequent devastation could have been lessened had they known more about the warning signs. Fast forward to today, and we can leverage machine learning, satellite technology, and drones to monitor volcanic activity in real time. In recent years, satellites equipped with thermal imaging have proven invaluable in detecting early signs of an eruption. These satellites can measure slight changes in ground temperature, capturing the buildup of magma beneath the surface. The European Space Agency's Sentinel satellites are already mapping changes in volcanoes like Kilauea, providing critical data for scientists and emergency planners alike. What if this technology allows us to predict eruptions with unprecedented precision? Drones have also changed the landscape of volcanic monitoring. Researchers can use drones equipped with sensors to collect data from the most dangerous areas, enabling them to understand the behavior of active volcanoes without putting human life at risk. This means that scientists can obtain ground-level information that enhances predictive models, leading to better preparedness for communities living nearby. Imagine being able to warn a community a week in advance of a potential eruption, saving lives and property. In addition, emerging technologies such as artificial intelligence are being developed to process vast amounts of data quickly. AI algorithms can analyze historical eruption data along with real-time observations and identify patterns that humans might miss. Through deep learning, these algorithms can predict future eruptions, even suggesting the likelihood of different eruption scenarios. What about the human element? Technology can also enhance community preparedness. Mobile apps are being developed to alert residents in real time about volcanic activity, providing them with vital information. The technology empowers communities by ensuring that they have the knowledge necessary to respond quickly and efficiently. Imagine a world where apps not only inform you of an imminent eruption but also guide you safely to evacuation routes. As we embrace these technologies, we must also acknowledge the ethical implications of reliance on machines for predicting natural phenomena. Errors in data or misinterpretations could lead to false alarms, causing unnecessary panic. Likewise, underestimating the potential of catastrophic eruptions could lead to complacency. Striking a balance between fear and caution is crucial as we advance into this new frontier of technology and volcano monitoring. In conclusion, the intersection of technology and volcanic threats holds immense promise. As scientists and technologists continue to innovate, we may unlock the keys to not only predicting eruptions but also fostering resilience in communities worldwide. But will we be proactive enough to harness these advancements before the next massive eruption catches us off guard? On April 10, 1815, a volcano on the island of Sumbawa in Indonesia erupted with a force that catapulted it into the annals of history. Mount Tambora unleashed an estimated 160 cubic kilometers of ash into the atmosphere, making it one of the most powerful volcanic eruptions ever recorded. What followed was not just a natural disaster, but a chain reaction that altered global climate and impacted civilizations worldwide. In the immediate aftermath, the skies darkened, covering regions as far as Europe in a thick haze of volcanic ash. Historical records document that 1816 became known as the year without a summer due to the drastic temperature drops caused by the ash cloud. Crops failed, food shortages ensued, and starvation spread, leading to societal unrest. This eruption didn't just impact regions close to the volcano, it had global repercussions, illustrating how interconnected our world is, showing that volcanic eruptions can, indeed, threaten civilization itself. However, what really makes the story of Tambora compelling is the human resilience that followed. Despite the hardships, communities adapted and learned to cope with these environmental changes. As we dive deeper into the details of the eruption, we will explore how this event reshaped societies and cultures, igniting a series of migrations and changing the course of history. The story of Tambora is not just about destruction, it's also about humanity's ability to survive and adapt. Could it be that the very challenges posed by nature might lead to greater innovation in our societies? As we unpack the details of this eruption, we will also reflect on lessons learned and how they might apply to our current understanding of volcanic threats in a rapidly shifting climate. Stay tuned as we turn our focus to the lessons that Tambora has to offer for our present and future, as we face new threats from volcanoes that could end civilization. Imagine a colossal, silent giant, lurking beneath the surface, waiting for the right moment to awaken. This might sound like a plot from a fictional thriller, but it describes the reality of the Yellowstone supervolcano. Nestled in the heart of the United States, Yellowstone is not just a beautiful national park,